Google's out here saying their new quantum computer might be messing around with, get this, parallel universes.
Yeah.
Like, whoa.
That's right.
Right.
Pretty wild stuff.
We got to unpack this.
Definitely.
We're going to figure out, what's real, what's hype.
Right.
And just how far down the rabbit hole Google's really gone, right? We'll try and figure out, is this a big scientific breakthrough? Or are they just messing with us,
Yeah, playing with our minds a bit.
I mean, I'm all for a good mind-bending thought experiment, but
Yeah.
come on, parallel universes.
Well, I think what's really fascinating is not just the speed of this thing.
Right.
But, what that difference in speed actually tells us.
Okay.
About how these quantum computers are actually doing their thing.
So how fast are we talking? I mean, give me the numbers.
Okay, so imagine a calculation that a regular supercomputer, like the most powerful one we could even think of, would take, 10 septillion years to do.
10 septillion.
Yeah, 10 septillion. Older than the universe itself, right?
Right. Okay. That's a long time.
Yeah. But Google's saying their quantum computer, Willow, did it in under 5 minutes.
So they're basically saying Willow is doing the impossible.
In a way, yeah. I mean, the thing is, this specific task, it's not like something that's actually useful, They picked it because it's something that normal computers basically can't do. It's like a way of showing off
the power.
The power, exactly, what quantum computers could be capable of,
Okay, so let's bring everyone up to speed here.
Sure.
You're listening to The Deep Dive,
Mm-hmm.
and we've been digging into this article
Right.
about Google and their claims,
Yeah.
all the buzz around it.
Lots of excitement.
Yeah, and skepticism.
Mm-hmm.
So Google's basically saying that Willow, this quantum computer, is working so fast because it's, well, not just working in our universe. They're bringing in the multiverse, like infinite parallel universes, all doing calculations or whatever.
Yeah.
It's like something out of like Doctor Strange,
I mean, it's a fascinating idea, right?
Absolutely.
So this multiverse thing, it's been around for a while, It's not like a new idea.
Right. I think I've heard of it.
Yeah. So it was this physicist, David Deutsch, who really kind of popularized it.
Okay.
And it comes from, trying to make sense of how quantum mechanics works.
Mm-hmm.
And it gets kind of weird. But basically the idea is that every time something happens at a quantum level, like a measurement, the universe splits. Yeah. It creates a new branch,
Oh, wow.
And each branch, it's a different outcome. So you've got a universe for every possible result.
Wait, hold on. So you're telling me there are like infinite versions of me out there?
Yeah.
Living different lives, making different choices?
That's the idea, yeah.
Okay, this is getting a little too Black Mirror for me.
Well, it is pretty mind-boggling,
It is. But how does any of this connect to like a physical computer in a lab?
Yeah, well, that's where a lot of the skepticism comes in. I mean, this multiverse concept, it's really cool. It's fun to think about. But, a lot of physicists are hesitant to just jump on board with Google's interpretation,
Right.
Like Sabine Hossenfelder, she's a physicist,
Mm-hmm.
and she says this whole calculation, it's impressive, sure, but it's like a party trick,
Okay.
It proves that Willow is fast, but it doesn't actually show us anything useful.
So it's like, okay, it can do this thing really fast, but it's not like it's solving world hunger or anything.
Exactly. It's like she uses this analogy of a hot dog eating contest, right?
Okay.
Like, imagine you win this contest. You're the fastest hot dog eater, but the hot dogs are made of something nobody actually wants to eat.
Okay, that's a good analogy.
It's a feat.
Yeah.
You won.
Good.
But are you actually getting any nourishment from it?
No.
So maybe Google's getting a little ahead of themselves.
Possibly, yeah. It's like they found this cosmic loophole, but they haven't figured out how to actually use it, Right. Like they've got this super fast car, but they haven't learned to drive it yet.
Exactly. And then on top of that, there's the issue of scale.
It's a scale.
Yeah, like how big these quantum computers are,
Okay.
So Willow, Google's computer, it works with 100 qubits.
Qubits, okay.
Yeah, qubits are like the quantum version of bits.
Like the ones and zeros in our regular computers?
Yeah, but they're weirder,
How so?
Well, a qubit can be a 1, a 0, or both at the same time. That's what makes quantum computing so powerful.
So that's how they're so fast.
Exactly. But the thing is, to really do something useful, like, design new drugs or model climate change, we would need millions of qubits.
Millions.
Yeah, all working together. Willow's only got 100.
So it's like comparing the Wright brothers' first plane to a jumbo jet.
Yeah, that's a good way to put it. We're still in the very early days of this whole quantum computing thing.
Okay, so baby steps. Got it. But, this isn't the first time Google's claimed they've achieved quantum supremacy, right?
Right. Back in 2019, they made a similar claim.
What happened then?
Well, IBM came along and basically said, hold on, not so fast.
Okay.
They showed that, yeah, a regular computer could theoretically do the same calculation. It would just take like way, way, way longer.
Okay, so maybe someone could figure out how to do this new calculation on a regular computer too.
It's possible, yeah. That's the thing with these claims. They're not always set in stone,
Right. So is there any way to explain what's going on with Willow without, bringing in parallel universes and all that?
Oh, absolutely. There are other ways of interpreting quantum mechanics.
Okay.
Like one is called the Copenhagen interpretation.
The Copenhagen interpretation, okay.
Yeah, it's a different way of looking at things, It doesn't need parallel universes to explain how quantum stuff works.
So it's like different theories, different ways of explaining the same observations.
Exactly. It's all about how we interpret the data,
So I guess what we're saying is Google's claim, it's exciting for sure, but it's not the whole story.
Yeah, there's a lot more to it.
There are different perspectives, different interpretations. It's not as simple as we found parallel universes.
Right. It's complex.
Yeah, we're getting into some deep physics stuff here. But the point is, Google's claim, it's just one piece of the puzzle.
And to be fair, they're not saying they've definitively proven anything, They're just putting this out there as a possibility.
Right. And despite all the skepticism, they're still pushing forward, right?
Oh, yeah, absolutely. Google sees Willow as a stepping stone,
Toward what?
Toward building even bigger, more powerful quantum computers. They want to see how far they can push this technology.
So it's like they're acknowledging the debate, but they're not letting it slow them down.
Exactly. And I think that's a good thing. It's pushing innovation,
It's exciting to see where all this leads, right?
Definitely. Quantum computing has so much potential, and it's still so early.
Right. So after this deep dive, I guess the question is, what do you think? Is Google on the verge of some crazy multiversal breakthrough? Or are they just really good at making really, really fast computers?
That's the question, isn't it? Here's something to think about, though.
Okay.
Let's just say hypothetically that Google is right. Let's say these quantum computers are actually interacting with other universes.
Okay, I'm following.
Could we actually talk to those other versions of ourselves, in those other universes?
Whoa, like interdimensional communication.
Exactly. Or what if we could tap into their knowledge, their experiences? It's a pretty wild thought, right?
It is. A little creepy, too.
Yeah, there's definitely some ethical stuff to consider there.
Definitely. So, a lot to think about.
A lot to think about.
And who knows? Maybe someday we'll have the answers.
Maybe.
Until then, keep those minds open and keep on exploring, folks.
That's the best we can do.
See you next time on The Deep Dive.
See you later.